The first speaker is Morio Toyoshima, Director General of Wireless Networks Research Center, National Institute of Information and Communications Technology。はじめに、国立研究開発法人情報通信研究機構ネットワーク研究所ワイヤレスネットワーク研究センター長、豊島盛夫様によるご講演です。それでは、豊島様、よろしくお願いいたします。
どうもご紹介ありがとうございます。NICT 情報通信研究機構の豊島でございます。本日はですね、私の方でスケーラビリティワーキンググループというワーキンググループのグループリーダーをさせていただいておりまして、その活動状況をご紹介させていただきたいと思っております。で、本日のアウトラインなんですけれども、最初にスケーラビリティワーキンググループのオーバービューと、それから今検討していますロードマップ、それから体制についてお話ししたいと思っています。で、その後にですね、現状のNTN、ノンテレストリアルネットワークのランドスケープマッピングっていうのをどういうふうに構成しようかということで検討しておりまして、技術ロードマップ、それから少し詳細な技術情報、であと、ランドスケープマッピングのサマリーということでご紹介、今、まだ検討途中でございまして、まだ発展途上でございますが、途中経過としてお話しさせていただきます。で、最後に本会議でもですね、国際協力、非常に大事ですので、国際協力ということで、NTN に関する協力につきましてお話しさせていただいて、締めさせていただきたいと思います。で、最初にスケーラビリティワーキンググループの活動のオーバービューですけれども、目的としましては、ランドスケープのマッピングを NTN に関して作るということを進めておりまして、で国内でですね、どの企業がどういう強みを持って、NTN に関する技術に貢献できるかということで、そういった企業さんをアイデンティファイする、見つけていくような活動にしたいと思っておりまして、でなおかつNTN のこのエリアをですね、国際協力でもっと活発にしていきたいというふうに考えております。でひいてはですね、NTN のグローバルコンソーシアムになるような役割として、このワーキンググループを発展させていきたいと考えております。で現状ですけれども、昨年度、2021年度、最初のトライアルとしまして、ランドスケープマッピング、どういうふうにしていこうかということで、4つのエリアを同定しまして、まず最初にですね、検討したのが昨年報告している内容なんですけれども、1つはハップス、それから HTS、ハイスループットサテライト、それから衛星 IoT、それから海洋ドメインということで、4領域でまとめさせていただきましたが、まだ取っかかりということで、今年引き続きですね、検討を進めております。で今年2022年はですね、ディスカッションを継続してさせていただいておりまして、それから新たにですね、このワーキンググループとして、メンバーの方に具体的に参加いただいて、議論を進めさせていただいておりますので、そういったメンバー間での技術の情報交換、そういったこともスタートしております。で、この先ですね、NTN を使ったユースケース、さまざまなホワイトペーパー、いろんなところで検討されていると思いますけれども、実際にさらにですね、異分野をまたいだような、そういう異分野交流の中での新しいユースケースをこのワークグループなりに出していきたいということで進めたいと考えております。でこれが技術ロードマップのスケジュールですけれども、これ横軸に大体8回ぐらい、今年度、ミーティングを予定しております。で具体的なアイテムとしては、情報交換から、上段の情報交換から始まりまして、であとですね、ランドスケープマッピングの検討としましては、NTN の技術情報、それからユースケースの検討、それからあと制度とかスタンダード、標準化への貢献ということで、各ミーティングでアジェンダを設定してまして、進めようと思っています。それから異分野交流としましては、この通信業界でない人の分野の方々をお声がけしまして、そういった異分野の方も含めて、ちょっとスタディセッションを行いまして、でそういった新しいユースケース出てきたら、それをですね、情報発信していこうというふうに、年度末まで考えております。 で、一番プライオリティナンバーワンの考えておりますのが、この技術情報をまとめるということです。それから、あとユースケースのスタディを行って、先ほどの制度とか標準化、それから異分野交流を進めていきたいと考えております。で、これがですね、体制ですけれども、一応ですね、各ワーキンググループにメンバーの方に主なコーディネーターとなっていただきまして、検討を進めております。で、一つは技術情報でして、ここはソフトバンク様、それからランドスケープマッピングにつきましては、NTN の技術については楽天モバイル様、それからユースケーススタディについてはファーウェイ様、それから制度とかスタンダード、これについてはソフトバンク様にコーディネーターとしてまとめていっていただきたいと思っておりまして、あと、情報発信、異分野交流重要ですので、そのセッション、スタディセッションをエリクソン様、エリクソンジャパン様、それから情報発信をビアビソリューション様にコーディネーターになっていただいて進めたいと思っておりまして、参加メンバーはこのようになっております。で、現状のランドスケープマッピングですけれども、これ、まだ発展途上ですけれども、3つ並べております。衛星ブロードバンド、それから衛星 IoT で、モバイルダイレクトの技術、それからハップスでございます。で、概要だけご紹介しますと、衛星ブロードバンドは、ジオの今までの衛星がハイスループット衛星になってきまして、それがさらにベリーハイスループット衛星、それから新たなワーディングとしては、ソフトデファインサテライト、こういったものでですね、デジタル化されて、さらにローコストが進むと考えております。で、さらに先にはですね、光リンク、それからKA、KU だけではなくて、V バンド、E バンド、こういったものも使われていくと思っています。それから当然、レオコンステレーションは低遅延でして、それから非常にブロードバンド、距離も近いですので、リンクバジェットも楽になりますし、非常に有望な手段となってございます。で、ここに挙げましたように、すでにスターリンクはサービス開始しておりますし、ワンウェブも含めて、ジェネレーション1がもうスタートしておりまして、この後ですね、ジェネレーションがセカンドになっていったり、あとアマゾン、最近打ち上げましたけれども、テレサット、こういったところが進めているのが現状でございます。それから衛星 IoT に関しましては、さまざまな企業さん出てきている、サービスが出てきておるわけですけれども、これはですね、3GPP の議論されてますように、3GPP のターミナルが衛星とか地上かかわらずですね、つながっていくような、そういった仕様しようという動きになっておりまして、注目されるところかと思います。さらに省電力のローラーとかですね、そういったテクノロジーも含めてつながっていくことになると。それからハップスにつきましては、やはり機体の向上、発展が必要でございまして、例えば太陽電池を軽くして、効率を上げていけば、次のジェネレーションのソーラーパワーのジェネレーションにつながっていきますし、それから狙うところとしては、400から500ワットパーキログラム、こういったところを狙っていて、次の世代でしっかり使えるようなものを探っていくということが重要かと思います。で、ちょっと文字ばっかりなので、これは説明しませんけれども、先ほどお話ししたような特徴をまとめているものでございまして、ワーキンググループではこういったまとめの表とかですね、こういった整理したものをまとめた上で、ホームページとかですね、この後発信していきたいと思ってますので、何か資料的な価値としても使っていただければなと考えております。で、この中ではですね、例えばマリタイム、話出てきませんでしたけれども、マリタイムはですね、やはりKU バンドもサービス開始されているところありますけれども、これからレオコンステで、ローレンテンシーで、カバレッジ広いサービスが増えていきます。で、先ほどお話した VHTS、あとソフトウェアデファインサテライト、こういったものでですね、容量は大容量に、それからただしコストは安く、こういったものがどんどん出てくると考えております。で、これも細かいですので、全部ご紹介しませんけれども、技術ロードマップのテクノロジーを整理するために、こういったものをいくつか準備したいと思っておりまして、 これは一つモバイルダイレクトの分野の整理の例でございまして、スペースモバイルさん、それからリンク、それからスターリンク、それからアップルグローバルスター、例として並べてございますが、見方としてはこういった表を出していきたいと思っておりますが、サービスタイプがレオで、3GPP のバンドを使っているとか、でユーザーターミナルも 3GPP コンパチですとか、サービスはテキストだったり、いろんなこういったことを整理してございます。それからこれはサテライトブロードバンド、衛星ブロードバンドの例ですけれども、これも例えば先ほどの VHTS ですとか、ソフトウェアデファインサテライト、これジオのケースだったり、あとワンウェーブスターリンク、レオのケースだったりっていうのをまとめて書いてございます。で例えば VHTS の SDS ですと、今ジオですけれども、KU、KA バンドが使われていて、でターミナルとしてはだいたい60センチから 1.2 メートルのパラボラアンテナが使われて、だいたい狙うところは150メガ BPS、それからレイテンシーは1桁、レオに比べると大きくなりますけれども、安定したカバレッジ得られますので、非常に衛星数は少なくてサービスができるというところでは、プライオリティを持っているというところでございます。で一つの例として、あと詳細技術、これは、これをいろんなプロジェクトについてまとめていこうとしていますけれども、一つは楽天さんの進められているスペースモバイルですけれども、これ AST さんと連携されているということで、168衛星を打ち上げて、730km の軌道で使うということで、3GPP コンパチということですけれども、衛星側は24メーターのフェイズドアレイということで、非常に大掛かりなものになっていると。でユースケースとしましては、モバイルネットワークそのまま使えますので、こういったものをカバーしていくということで、一つモバイルのダイレクトの衛星サービスとしては重要な話かなと、側面かなと思います。で標準化の方も無線通信の規則の 4.4 に書かれているとかですね、そういったことをまとめていきたいと思っております。で最後にですね、国際協力の重要性ということで書かせていただきましたけれども、国際協力、やはりですね、いろんなオペレーターの方、ユーザーの方からいろんなコメント、意見をお聞きしながら進めていく必要があると思っています。で国際協力になりますと、さらにどこの国の、どこの企業、どこのパートナーさんと協力していくか、技術的なエリアとして協力できるところがあるかということを同定していくのが非常に大事になってきます。ですので、こういった国際カンファレスの機会にですね、可能な方々、国々の方々といろんなその技術領域ですとか、そういったことを議論しながら、日本とまた海外が国際連携できる方向、相手をですね、探っていきたいと考えております。それからあと、スケーラビリティワーキンググループですけれども、こういった技術を検討したものをですね、情報発信していきたいと思っていますし、どうやったらより良い国際協力ができるかということを検討していきたいと思ってますので、皆様からご意見、アドバイスよろしくお願いいたします。ひいてはこういったのがNTA のグローバルコンソーシアムになるような役割として、働き、ワークグループの働きが貢献できればと考えております。でこれ一つの昨年も示した例ですけれども、例えばユーザーさんが何か問題があったと、でプロブレムがあったといったときに、例えばこのワークグループの中にご相談いただければ、その中でソリューションを少し検討させていただきまして、その時にはオペレーターさんも含めてメンバーにおりますし、実際の企業さんにソリューションをお伺いして、もし可能だったらダイレクトにそのソリューションの答えが分かるですとか、もうちょっと企業さんだけでは無理だという場合、例えばスケーラビリティワークグループの中で、それちょっと制度的な問題だったり、あと標準化の問題だったり、そういったことがありましたら、例えばそういう団体にプロポーザルをしたり、あと相談、関係機関に相談したりして進められることもできるかなと考えております。 でこういった活動を情報発信することで、こういったNTN 技術の集約されたワークグループの場所として、皆さんに活用していただけるように、認識していただけるように活動していきたいと考えております。はい、最後にまとめますと、私の方からは、スケーラビリティワーキンググループのご紹介としまして、検討していますロードマップ、それから体制、それからロードスケープマッピングの現状、少し詳細な情報を、まだ発展途上ですけれども、お伝えさせていただきました。それから国際協力、非常に大切ですので、この NTN の実際のアプリケーションを見出すにはですね、グローバルな連携が必須だと思っておりますので、どの領域かこれからもっと議論していきたいと思いますが、グローバルな IoT、それから衛星の 5G とのインテグレーションですとか、量コンステ、そういったところの領域、どんどんこれから発展していくと思いますので、議論させていただきたいと思います。でひいてはNTN のグローバルコンソーシアムの役割を持つようなワーキンググループにしていきたいと思っておりますので、ぜひですね、皆さんのご参加で成り立つワークグループですので、いつでもご参加いただけるようにお待ちしておりますので、ぜひWelcome to join Scalability Working Group Anytime ということで、最後締めさせていただきます。どうもありがとうございました。
Thank you very much, Mr. Toyoshima. 豊島様、ありがとうございました。続きまして、ロバート・ボッシュゲーム、チーフエキスパート&ヘッドオブ 6G、アンドレアス・ムラー様によるご講演です。ムラー様はオンラインでのご登壇です。Next speaker is Andreas Muller, Chief Expert and Head of 6G, Robert Boschgem. Dr. Muller will be speaking from online. Dr. Muller, please.
Right, yeah, hello everyone, and thanks for having me. It's a great pleasure to be part of the conference today. And I'm very sorry that I cannot be in Japan today because I'm currently traveling in the United States, but that's the good thing about the new communication technologies, that also remote participation works pretty well these days. And I have the pleasure to bring in a little bit of different view to the event because Bosch is not a classical telecom player, we are not an operator, we are not a technology provider, but we are one of those vertical industry players that came into the game with 5G, and now we are there and we will not go away anymore. That means also 6G certainly will become a very important topic for us. And I would like to focus especially on the mobility sector and on the industrial domain a little bit, which are the two key areas from the Bosch perspective. But before talking about 6G, let's start with a brief reality check of 5G. So here on the left-hand side, you can see a vision picture that has been published by Etsy in 2018, which gave an overview of the 5G vision that we had at that time, right? And the vision, of course, was that 5G will revolutionize all these vertical industries, including the mobility and the industrial sector, including the smart grid, and many more, the healthcare sector, and so on. So this is all about a vision of 5G. But if you look at the reality today, it pretty much looks still like this on the right-hand side here. So the main business today, as we speak here, is still in the classical consumer business, and the main application, the main use case of 5G still is about connecting mobile phones. And of course, now you may question, okay, if even 5G in the different vertical industries is not a reality yet, so why should we bother about 6G then? And I think what we see here is a classical hype cycle. So there was a huge hype behind 5G, especially also 5G for vertical applications. There were inflated expectations. And then there was a lot of disappointment because maybe the things were not available as soon as people would have liked it to be available. Maybe also what was available and what is available is not exactly what has been promised upfront. So therefore we went through this phase of disillusionment. But the good news is that from my perspective, we are somewhere here for the vertical industries. Of course, it's always very hard to say. When we are in the phase, it's always easier to say in retrospective where we have been. Consumer 5G certainly is a bit more ahead already, but now things are going up again. That means now we are getting more realistic. There are more solutions becoming available and so on. And I still believe there's also a very bright future for 5G for different vertical industries. And if you look at what is still missing today, there are certain aspects here on the right-hand side. What we currently have with 5G, of course, is pretty much release 15, especially the chipset side. I haven't seen many release 16 chipsets yet, but only with release 16 and later on with release 17, we will see new features that really make a difference to different vertical industries, right? So the release 16 will bring the low latency, the high reliability that we need for closed loop control applications. We will have time-sensitive networking. We will have high accuracy positioning with release 17 to reduce capability mode and so on. So there are many things in the pipeline that have been standardized already, but we are still lacking the implementation of these features in the chipsets and the infrastructure components. And once this is available, this will certainly give the whole development a push. At the same time, and this goes hand in hand with this, there is a lack of a device ecosystem in different verticals, right? So if I'm a factory owner, of course, I can set up a private 5G network in my factory, but there are not too many industrial components that I can connect to the network, right? So not so many robots integrating 5G, automated guided vehicles, and so on. So it takes some time until we have the device ecosystem, and a prerequisite in many cases will be the available of these release 16 and at some point also release 17 chipsets. We also see that things are still a bit expensive here and there, which is a normal development probably because it's a new market and everybody first of all tries to get as much as possible out of the market. That means the initial prices are certainly higher than what they could be after some time. And here, from my perspective, we already see a drop in prices in different areas, which is a good thing. And also at the end of the day, in many verticals, the vertical users do not just want to buy a 5G network or a component integrating a 5G module. At the end of the day, it's about having a use case, a problem, a solution for a specific business problem. And typically this solution is an end-to-end solution. That means it includes the network, it includes an end device, but it includes also many other things beyond this. And also here, there's still the need for more integrated end-to-end solutions addressing really the needs of the vertical industries. So therefore, there's still a way to go. But as I said before, I'm very confident that 5G for vertical industries will become a reality. It maybe just takes a bit more time than originally expected. So, but anyway, this talk is about 6G and the conference about beyond 5G, of course. So what can we learn maybe from these developments that we have seen now with 5G, and also that maybe some things took a bit more time and that we went through this hype cycle with 5G. So can we have some lessons learned here for the developments towards 6G, which are now starting, of course. And I think what is very important is to continue what we have started in the last couple of years on the 5G side already, so that there's a very close collaboration, not just between the different countries around the world. I think international collaboration certainly is also very important, but also between the different stakeholders in the ecosystem, and especially a very close collaboration between the ICT industry and the vertical industries. Also, we should be realistic, and especially the ICT industry should be realistic in what they promise to the vertical industry, so that you don't promise heaven and earth, right? Otherwise, there will be a lot of disappointment at some point in time. And we should have a strong focus on the return on the invest from the very beginning. So it's not just about developing some fancy new technologies that maybe perform much better than anything before. So that's nice to have. But if it's too expensive at the end, then there will be no market, and then it will all be wasted effort to some extent. So therefore, we should have a strong focus on the business cases from the very beginning, and of course, a close collaboration between the ICT industry and the vertical industries helps here a lot. There are two ways basically to improve the return on invest. We can try to bring the costs down, and this is also something that we should focus on from the very beginning, not just the new features, new capabilities, and so on, but also how can we maybe deliver the same performance as today, or as we will see with 5G, release 16, release 17, but at a significantly lower cost. At lower cost in terms of CapEx, the capital expenditures, but also the OpEx, the operational expenditures. And here, things like artificial intelligence, machine learning for automating things, and so on certainly may help a lot. On the other hand, of course, we may increase the value of the technology, the value that comes along with 6G in future. And there are basically two ways to do this. It can be more of the same. That means having a similar value proposition, but with better KPIs, like even lower latencies, even higher data rates, even higher reliability. But here we always have to carefully see, do we really need this, right? It's very easy to say 5G has promised 1 millisecond latency. Now 6G should be better. Let's go for 1.1 millisecond latency. So that would be a target. And certainly there are some use cases where this is needed, but maybe it's not really a huge number of use cases, right? So we really should question, is this then the right thing that we are doing? So therefore, more of the same is something that we need, especially high data rates. Certainly there will be applications with the metaverse and so on, but we also should always carefully challenge what we are doing. What is maybe more attractive from my point of view are the completely new capabilities that 6G will come along with. And this is something I want to focus on the following slides. Now, 6G, of course, is a broad topic, and many things have been addressed during this conference already. We just heard about non-terrestrial networks, of course. They provide global coverage and have also a unique value proposition. So therefore, I don't want to focus now on all aspects of 6G in my presentation, but I would like to highlight 3 key areas, key capabilities that from our point of view may really become a game changer with 6G. And the first one, and this is the one I will mostly focus on in my presentation, is integrated sensing, so that we use a 6G system not just for communicating, for transmitting data, but also for sensing the environment, that we integrate radar functionalities into the 6G system. And that, of course, can be in a device, right? So that we bring communication and sensing closer together, that maybe we can do both things using the same waveform. But it can also be that we have a close collaboration between different devices, which then jointly sense the environment using cooperative radars, cooperative sensing, and so on. And I will outline this a bit more in detail on one of the next slides. A second topic that is very interesting and promising is this network of networks paradigm, so that we have not a monolithic network as we had it in the past with just the public networks maybe that have been built by the operators to serve them all, but it's more diverse network structures serving different needs, right? Of course, we will still have public networks. We will also still have private networks, which started with 5G. And from my perspective, private networks should be more and more the center of the developments, offering tailored solutions on a local basis for different applications in different verticals, for example. But we will have the non-terrestrial networks, of course. We should also think about integrating and managing non-3GPP networks, following this network of networks paradigm. And we also see the trend towards the subnetworks, which is very attractive. So even smaller network structures, which can be something like a body area network, which can be maybe an in-vehicle network to connect sensors, actuators in a car using a local 6G subnetwork, or could be for providing high-performance connectivity in a production cell in a factory, for example. And the third topic that I would like to highlight is that we change basically the general paradigm. So 5G and the previous generation, this is always an infrastructure that has been provided to connect things. And with 6G, I think this should change into more a platform view here. So that 6G really is a platform. What does this mean? We still have the infrastructure here as the basis, so providing connectivity, compute, and in future also sensing resources. These resources need to be managed and to be orchestrated. But then we build different layers on top of this. And these layers are needed to some extent for managing and optimizing the network itself. So things like digital twins of the network, artificial intelligence, machine learning for optimizing network operations and so on. But once we have the functionalities in the network, we can also expose them to the end users, to the vertical users, in order to simplify their development and integration of corresponding use cases, right? This could be the digital twin as a service. This could be compute as a service, providing computational resources, artificial intelligence as a service, and basically everything else you could imagine as a service. And this is, of course, a major change, because then 6G is no longer just an infrastructure, following an infrastructure as a service business model, but really will become a central platform as a service, offering all kinds of services. It may then become this central digitalization platform for many different vertical industries. So these are really 3 key areas from my perspective. And now I would like to focus especially on the sensing part, which is maybe the most exciting development these days, at least from our point of view. So if we integrate sensing functionalities in a 6G system and in a 6G network, for example, what can we do with this? So these are some thoughts and some ideas, that many use cases have been published also by other players here. So this is a few on a smart city, smart mobility scenario. We could use it, for example, for just getting additional information about environment, right? We could detect free parking lots using the same system that we have in place anyway. We can do traffic monitoring. We can also improve the safety of the traffic, of course, to enhance existing automotive radars. It could be used to interact with the environment via gesture recognition, for example, and many more things. So this is really just a subset of ideas what could be done with this in reality. And I think the challenge now is to see what is realistic and what is maybe just a fantasy, right? So coming back to what I mentioned before, that we should have realistic promises and a realistic understanding of what really is feasible and what not. If you look into the industrial domain as another application scenario, it looks a bit, sorry, there's some latency, a bit different. Also here, many things that we could imagine, right? So, for example, establishing virtual safety zones that you can detect if somebody is getting too close to an industrial robot, for example. We may integrate sensing into an automated guided vehicle. It may be used to create a digital twin of the environment. We can do stock monitoring to see what kind of boxes are there, how many boxes are there, and so on. And again, gather a lot of additional information out of the environment. Now, what does it actually mean, integrated communication and sensing, as we typically call it? Basically, to us, it first of all means we bring connectivity and sensing closer together. And there are many use cases where we have both already today. Take a car, for example, as an example, right? So a modern car has a connectivity control unit, it has connectivity, and it has several radar systems typically. But today, these are separate systems. So separate devices, they are not really connected, they're not really interworking. And it works okay, right? But with integrated communication and sensing, we can now improve things if we just bring communication and sensing closer together. And I would like to continue with this automotive example here. In another step, we can say, okay, we still have separate systems, separate devices, but now they know about each other and they can interact with each other. And there are basically two major flavors that we can imagine here. So one is called communication-assisted sensing. That means we use the communication capabilities to optimize the sensing. And if you have here the cars again, right, there might be two cars, and they may communicate with each other, they may synchronize themselves. And if we do this, we can do something called bistatic sensing. So typically radar is a monostatic radar. That means a car emits a signal, it's reflected, and the same car receives it. With bistatic sensing, it means transmitter and receiver are separated. The car transmits a signal, it's reflected here, and the reflection can also be received and evaluated by this other car here, thanks to the synchronization that they may achieve via the communication link here. So this then allows us to get a more efficient and better perception of the environment. Likewise, we could do it the other way around. So what's called sensing-assisted communication. So here we can exploit information that we gather from the sensing of the environment to optimize the communication link here. So this example, we may sense using a radar that there's a truck driving there, and the truck may interrupt the line of sight connection between the car and the base station. And this is something we can predict, of course, if we sense the environment, and then we can proactively react, for example, by doing a proactive handover from that base station to another one in order to ensure a high reliability, high quality of service. Then we may also do resource sharing. So now we are bringing them even closer together, sharing some resources like spectrum resources, right? That we use the same frequency band for communication and sensing. Previously, we always had separate bands for either communication or sensing. So this will allow then for a more efficient usage of the spectrum resources. And we may even think about reusing some hardware resources in the extreme case that we have a single chip that can do both communication and sensing. And finally, the final step, this would then really be the deep integration of communication and sensing that we have, for example, a system where we switch between the communication and the sensing mode. This would be then an orthogonal integration in the base station, for example, or in the final stage, we could even have a single waveform that can do both at the same time. That means while transmitting data from A to B, we can receive the reflections, and this way then also sense the environment, which is then, of course, the most efficient way that we can realize. So I think that's always important to understand. Integrated communication sensing is not a single approach, it's a family of approaches with different challenges, but also different opportunities then. Now, what are general benefits that we see in this? We can improve the sensing performance. I mentioned this. We can improve the communication performance. We have potentially this higher resource and cost efficiency. We may even replace then some other sensors, other systems. In a factory, for example, we may replace light fences if we can establish such virtual safety zones using integrated sensing. We may replace cameras because maybe such a sensing is sufficient to sense the environment, or maybe even classical radars in some applications. And of course, a big benefit is also that just by standardizing things, and this has not been really standardized in the past, right? We can already do a lot. And standardization, of course, is very important for interoperability. And also it may help us if it's integrated into a 6G system, because it's then not just a standalone standard for a connected radar, for example, but it's a complete solution, a more complete solution that can then more easily be managed and orchestrated. Now, if you look at a timeline, this is a possible standardization roadmap. Of course, things are still developing, but from what we see and what we hear from other players, this is what it could look like. Today, what would be possible already is a proprietary coupling, for example. So I mentioned this communication-assisted sensing, sensing-assisted communication. In principle, that would be possible today. It's not really being done today because we are lacking the standardization, right? But even with 5G connectivity, we could already have some first low-hanging fruits here, some first achievements. What is currently happening in 3GPP towards release 18 is the first study, looking especially at use cases and requirements. And Deutsche Telekom is actually driving this study item in 3GPP. And then if you look at the future, the next releases, there could be a first activity towards integrating this on the network side in release 19, then maybe on the device side in release 20, and then release 21, which might be the first official 6G release in 3GPP. That may focus on joint communication and sensing, so that it's really done with a tight integration and maybe even with a single waveform. And then, of course, there will be certainly also evolutions and further enhancements in future. Now, in general, there are a lot of challenges that need to be addressed, right? And typically, we always look at the technical challenges, and certainly there are many. I briefly outline some of them. How do we do accurate time synchronization? How do I design a waveform that is optimized for all these things? How do I do this or realize this then in a chip? So many interesting questions that need to be answered, but it's not just technology alone, right? So there are also regulatory challenges. For example, the spectrum that may be used. I mentioned this before. Today, we have either allocations for sensing or for communication. This might have to change if we want to do both in the same frequency band. Also, there might be privacy-related regulations, right? So is it okay for a state, for a government, for a network operator to sense always the environment, where you can also then see people and so on? There are also many security-related challenges because, of course, these are then complex systems, connected systems. There might be new security threats which need to be analyzed, which need to be dealt with in an appropriate manner. There are business-related challenges. So we have to find good business cases for having access, for example, to sensing data, and also societal challenges, right? So again, questions about societal acceptance. There are concerns, especially in Germany, often there are concerns about the exposure to electromagnetic radiation, and also, of course, concerns regarding the privacy that I mentioned already. So therefore, it is very important to have a look and a holistic view on all these challenges right from the beginning in order to maximize the probability that it will eventually become a success. So maybe I skip this here. This was just be an example then for some more details, but since I'm a little bit running late, just would like to highlight the last slide here. Very sorry for this. So Markus Breitbach outlined before a new 6G project in Germany that is funded by the German Federal Ministry of Education and Research. I would like to highlight two additional ones out of the same program. And these are especially two projects where Bosch is also heavily involved. One is 6G Anna, and I believe that also Ina Schieferdegger will certainly say a few words about these projects later on. 6G ANA is the German 6G Lighthouse project, which has a focus on the big picture, including an integrated end-to-end architecture. So the idea is to really also look how the different building blocks, these new technologies, really fit together and how we can build a complete solution out of this. So this started in July this year already with a duration of 3 years. It's a rather big project, 37 million euros project volume. And we're looking into all these aspects here, right? This, the access network, this network of networks paradigm, including the subnetworks that I mentioned before, and also ways to automate and to simplify the operation, for example, of a network, which helps again to bring the costs down. You can see here the participating partners. So in boldface here are maybe the bigger ones. Nokia is leading the consortium. We have Ericsson, we have Airbus, Bosch is part of it, of course, Rohde & Schwarz, for example, Siemens, Vodafone, and many more, including universities, SMEs, and other companies. Then another one, which is actually led by Bosch, is called 6G ICAS for mobility, 6G integrated communication and sensing for mobility. So this has a focus on this integration of sensing, especially for automotive applications, but also for drones. And we look here especially at the integration of sensing on the device side. So less on the network side, but really on the device side, and also the integration into the side link, which is the direct communication, of course, between different devices. We are following here different approaches, more communication-centric approach, sensing-centric approach, similar to what I mentioned before. This started just this month, so it's a brand new project, a bit smaller than 6G ANA, but still fairly big, I would say, 14 million euros overall cost. And here you can see the consortium. As I mentioned, Bosch is leading the consortium. NXP is, for example, part of it. And I think here we have already a good example for also German-Japanese collaboration, because also Denso is part of the consortium as well, apart from other players. And that's pretty much it, what I've prepared for today. So thank you very much for your kind attention.
Thank you very much, Dr. Muller. 村様、ありがとうございました。